I remember my sister having this paper.
Yep.
Which is the front of her binder.
Yep.
I remember looking at that.
All right. What we are going to do is we're going to do something called electron configuration. What that essentially is we're going to show where each electron in an atom will be located. Okay? Now, where an electron is going to be located has everything to do with energy. Because we know things want to be stable, correct?
Yeah.
And stable means what from an energy standpoint?
Zero charge. Equilibrium.
What's stable? High energy or low energy? Low. Right? If you go into a room, a stable room will be one that is got low energy. If you've got a bunch of little kids running around, it's probably a pretty unstable environment, right? But if you walk into a room with a bunch of grandparents, it's pretty stable. Until they die.
Wow. That depends
I
on.
think little kids are more stable than us.
Little kids are more stable
Like
than
stable.
stable, okay. I'm thinking from an energy standpoint. Does that make sense? Old people don't have quite as much energy as little kids. I'm learning that as I get older. I don't have the energy I did when I was your age.
Not even old.
No, but you feel it. I'm telling you, you literally do feel it.
I feel it.
Okay? A change in your energy level as you get older. Like you need to sleep more. I went to bed at like 8:45 last
I have a
night.
hard time
Last night?
sleeping on that.
Or 2 nights ago, I
I was
think.
about to say, you're out. Yeah.
I fell
Yeah,
asleep
2
on
nights ago.
memorize.
We had a really good conversation after you guys left.
Seriously?
Yes, really great conversation. I got to pray with the guys and everything. It was awesome. You guys left!
Whatever.
Alright, so here's how this works. We need to be able to figure out how each energy level gets filled from an energy standpoint. The orbital that has the least amount of energy gets filled first. Does that make sense? It's not overly difficult. So the problem is which one gets filled first and how do they fill? Alright, so that's what this is saying. We're going to arrange electrons based on how they fill these orbitals. Okay, I love saying this. Like, act like you got like marshmallows in your mouth and try to say that. Okay? What this is saying is electrons are going to fill the lowest energy orbital available or first. Okay, so what we need to figure out is how does it progress? Remember how I said the reason why the D block is right here, even though the first one appears in the third, is because of energy and how it fills? Well, if you look at this, as energy goes up here, what gets filled first? The first S, that makes sense, right? 2S gets filled, then 2P, that makes sense. Then 3S, then 3P, but why not 3D?
Because
4S has lower energy than 3D. So this is why this D block appears in the fourth energy level when realistically we say it's 3D. Okay? Now, are you going to have to memorize all this? That would be really difficult to memorize all that. Here's a sweet little trick called the diagonal rule. Ready for this? You guys, I know I have it down on there for you, but you need to draw it because I'm not giving you this sheet on a test. You need to be able to draw the diagonal rule, so get some practice. Ready? Here's how you do it. Just don't write anything yet, just watch how I do it. There are 7 S sublevels. 1S, 2S, and how would I know that there are 7 S's? You would look at that what do you call it, a coffin? There are 7 S's, right? Okay. Where does the P start? The second, and does it go all the way to 7?
No. Yes.
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 Oh, diagonally they're going to cross.
Okay. Then where does the D start?
The second, third. Oh shoot.
And it goes down to where?
6.
So it stops at the 6, and you can see that from your little coffin. I keep forgetting. Where does the F start?
4th and 5th. There it is.
So there's only the 4th and 5th. And so I would write that in. Now watch, everyone's eyes, how you do this diagonally. Okay, and you put an arrow through them diagonally. Once you put this in, just get practice with it, and then I will show you how to read this. Tanner, this is more valuable here. Because if you cannot do this, if you do this wrong on your test, everything that I taught you today and yesterday, you're going to get everything wrong. You literally will get everything wrong if you mess this up. Okay? So figure out the pattern that works for you to be able to get it right. You should practice it a few times. That's a better gauge.
Did it wrong.
Did it wrong?
I did it right. I'm just going to do it again so I know I've done it. 4 feet.
As long as you can read it, man.
I can't.
You can't?
6, 7. 4 out.
Like,
5,
You can read it. I think you can read it. But you can practice. Yeah, the more you practice it, the better you'll get at it.
5 out. 60.
you know, I didn't cough all first or second hour. It must be this classroom.
Oh, yeah.
Why?
All the chemicals we used to
Nice.
have in here living around.
Okay, I did it right. Did it right. I added a.
That's ironic that it ends on 20.
Why?
Because normally our class ends at 10:20.
Oh, alright.
Oh.
Okay, you get it? Can I show you how to read this now?
I added a.
Except for that we're on
7D.
shorter day. So,
Sure.
on a normal day.
You're right.
Okay, I need a color.
Okay? I want everyone to drop whatever they're doing, and because I need to show you how to read this. Okay, this is a nice tool to tell us how electrons fill orbitals, which one's the lowest, and how it fills it. So you would read from tail to tip, and then you would keep going tail to tip. Let me show you. The first one that gets filled is what? 1s. Does that agree? Okay. Then you go up here. What's next? Does that agree?
Yeah.
Then you go and fill what?
2P.
Does that agree?
Yeah.
Followed by?
3.
Does that agree? Okay. Come up here. 3P. Does that agree?
Yeah.
What comes next though?
4F.
For S before 3D. Everybody see it? So you don't have to memorize this, you gotta know how to do this and how to apply it. Okay, I can keep going down. Where was I? 3D, 4P, that's right. 5S now comes before 4D. Everybody see it? So if I needed, to figure out how many electrons or where the electrons in boron would be, we would use this. Okay? Questions on how to read that? I wish Tyler was here.
You missed a really bad day.
I am going to make sure to get today's video and tomorrow's video up on Schoology because this is important. So I'll make sure to get that up, but it probably won't be till the end of the day or like end of the school day. Okay? Alright, Pauli exclusion principle. What this is saying, that a maximum of 2 electrons may occupy a single atomic orbital, but only if electrons have opposite spins. And here's the nutshell of this. If I've got an electron in one orbital, we show opposite spins with opposite arrows. And what that simply means is it's really an electric or magnetic thing. They cannot be spinning the same direction because that throws the magnetic field off, and it's much more complicated than that. But at this point and at this level, that's all I'm going to say about that.
Well, that would make sense.
Okay? And it has to do with the electric and magnetic stability within the atom. Okay? Hunzru says single electrons have the same spin, must occupy each equal level orbital before additional electrons are added with opposite spin. So let me represent the 2 p orbitals. This is one of the orbitals, that's the second orbital, and that's the third p orbital. Does that make sense? Because we know p has how many orbitals? 3. What this is saying is that it fills each orbital with 1 electron before it goes back and fills them with 2.
Really?
This is what it doesn't do. It doesn't fill the first orbital with 2 and then do that.
So we're
Because it's actually more stable and lower energy to have an electron in each. Because as soon as you put that second electron in there, you've got some of that magnetic stuff going on. And so it's higher energy to have 2 versus 1 in there.
So what we're going to get to is how many electrons are in the P sublevel of the second energy level.
That's what we're doing today. Yep.
In the second orbital.
Yep.
Yes.
Going like,
Okay. We can now we don't know where the exact location of that electron is in each orbital, but we know it's in the orbital. Okay. All right. Orbital rotation. There are 3 different things we're going to do today: orbital rotation, electron configuration, and noble gas. I will try to show you all 3. We're going to take a day tomorrow to review this. More in-class problems than anything. So if you feel a little bit overwhelmed today, that's not an uncommon feeling. Okay? You will get it, I promise. This, once you figure it out, this is not one of the more difficult ideas. It just seems difficult up front because you've never done it. So let's see. Let's start with the easiest of the group. Electron configuration. I don't know if you have, I don't know what room you have.
Have a little bit.
Space. Let's say let's do a small one. Let's say we're doing carbon. We're trying to figure out the electron configuration for carbon. Okay, so follow along here as we begin. Very first thing, if we're trying to order where the electrons are located, is probably to identify how many electrons it has, right? How many electrons does carbon have? Did everyone see how you would identify electrons? Okay, you look at the number of protons and electrons should be the same. Now, can I make you do an electron configuration of an ion?
Oh.
I could.
No.
This probably will be in one of your homework problems. Okay, it's got 6 electrons. Here's how we do this. We look up here and we identify that the first electrons are going to go where? The first energy level, S sublevel. Here's how we write it. There's my 1s sublevel. How many electrons can fill an s orbital?
2.
I've accounted for 2 electrons. So this is the energy level. This is the sublevel. This is how many electrons I have in that sublevel. Make sense? Okay, what gets filled next? 2s. There's my energy level. There's my sublevel. And how many fill an s?
2.
How many electrons have I accounted for so far?
4.
4. How many more do I need?
2.
Okay, what fills next?
2p.
2p. Now we know 2p can have a max of how many? 6. But do we need to fill it with 6?
No.
No. How many do we need to fill it with?
2.
This would be the electron configuration for carbon. And let me show you how you can figure out if you did this right. Go to the second energy level. Find the P sublevel, which we said was where? Starts here, correct? How many did we say we put in the P?
6.
How many did we put in the
We
P?
put 2.
1, 2.
There it is.
Oh.
Okay? That's just the first one. Let's do. Oh shoot. Let's do a more difficult one. Let's see. What do I have in here?
Oh, this is.
Well, I mean, we only did 6 electrons.
Wait,
Give us
so
a juker.
what's like
We
the
should
most
do
electric?
Snarkus.
Let's do all 3. So that's electron configuration. Let's do orbital notation. Orbital notation. Oh shoot.
Orbital.
Yeah, but what's the thing for the next one?
I think it's just normal.
Okay, so
One home game, one.
orbital notation is the one that shows the spin rule, which is Hund's rule. Okay, here's how we do orbital notation. Same thing, I'm still doing carbon, I still have to identify these 6 electrons, but it looks a little bit different. We will represent an orbital with a little dash. That's what I was showing you earlier. So the first energy level that gets filled is the 1s, correct? How many electrons?
2.
1 electron, 2 electron. Notice what I did there.
So that's just a different way of writing.
Yeah, it's just a different way of writing what we just did.
Is it all the way down?
Okay? The only difference is here I'm showing opposite spins, and there's no way for me to show opposite spins here, right?
Yeah.
Okay? That's 2 electrons. What fills next?
Wait, so this is carbon again,
Yep, still doing carbon. I'm going to do carbon for all of them. Hey. Okay? 2s gets filled. Again, same thing. How many electrons? 2. How many have I accounted for so far? 4. Okay, what comes next based on the diagonal rule? How many orbitals are the 2p? So here's how we would do this. 2p has 1, 2, 3 orbitals. But how many electrons do I need to complete this?
Only 2.
Only 2. Would I go like this?
No.
Why don't I do that?
It's not stable.
The Hund's rule, it's more stable from an energy standpoint to fill each orbital with 1 before you would go back. Well, do I need to fill this one with 1? No, I only needed 6, so I'd be done now.
Could you just erase the third orbital? Or would you?
No, I want you to still have it there, because remember, even if,
It's still there.
yeah, it's still there, okay? All right, most difficult one,
These are fun.
noble gas notation. Okay, once you get these down, they're actually the simplest in that they make your work a lot easier because it's an abbreviation. So what you do is you abbreviate based on noble gas. So here's how you do this. Find the guy you're looking at. We said carbon. Your starting point will always be an energy level up and the noble gas. So if I were doing gallium, what noble gas would I start with?
Whatever.
Argon. If I was doing tin, it'd be krypton. If I was doing bismuth, it would be xenon. Okay? But since I'm doing carbon or anything in the second energy level, I would start with helium. So here's what we do.
So it's up 1 to the end.
You put in brackets your noble gas that you're starting, not neon, wow. And what this does is it abbreviates the electrons all the way up to neon, or helium. How many electrons does helium have?
1, 2.
2, right? So I like to put a little 2 up there to know that I am starting after helium. So this and this are very much related. This one's just a simplified version of it. Okay, here's how you figure this out. You always look at your noble gas and which energy level would it have completely filled? Which sublevel? 1s, right? Isn't that 1s filled right there with helium? So we would start after 1s. What comes after 1s? 2s, 2 fill, and 2p, 2 fill. 2, 4, 6. Now this is not a huge approximation because we only simplified 2 electrons, but if I was doing 10, I would have simplified 36 electrons. And I would just have to go from 36 to 50. Okay, we'll get to that.
But you still really,
I'll show you.
you just account for.
So this is abbreviating that.
But why? Why do you have to use helium? Doesn't that make more
Well, it's just they just give you a
For this
constant
one, it
instead.
seems like it's more complicated, but.
Yeah, once we
Like,
do
I
all
mean,
that-
it makes sense, but like,
Ooh,
why?
I want to keep this.
Oh, yeah.
I'm gonna keep those. We're gonna do one more example of each.
So you're gonna want to use noble gas when you have a big one.
Well, I'm gonna specifically ask you to do each of these. So, but yeah, if you had the choice, noble gas would be the best way to do the big ones. Yep. Okay, which one? Look in your notes. What is my? I have germanium.
Yeah.
Okay, let's do germanium. So GE.
Where? Oh, there it is.
GE. E, which has how many electrons?
32.
All right, so this is going to take a little bit, isn't it?
Shouldn't they?
32 electrons. Whoop, done.
I'm getting started.
Okay, remember, we are going to follow the diagonal rule. It tells us how these fill. Right? What fills first, everybody?
1s,
1s. And max electrons for that would be?
2.
Everyone following? I would focus more on paying attention than trying to do this on your own at this point. You're going to get plenty of practice, I promise you. Okay? Marty, what gets filled next?
2s.
And how many can fill it?
2.
So I've accounted for 4 of the 32, correct? Shelby, what gets filled next? 2p. How many can fill the p? You have to go back and look, that's fine. Max can fill the p.
2.
Well, 2 fill each orbital, but it has 3 orbitals, right? So a max of what?
6.
6. Okay, what comes after 2p, Tanner?
3s.
And how many can fill the s? Brevin, what comes after 3s?
3p.
And how many can fill the p?
6.
Let's count where we're at, right? Because we don't want to go over it. We got 4, 10, 18. We got a ways to go yet, correct?
Yeah.
Well,
After 3p, what comes after 3p? 4s. How many fill it?
2.
Yes.
Could you just go until you count it's in the P block and it's 2-way? Or is this
Yeah.
gonna be equal?
Okay, that's fine. I just don't want to, get too far ahead of some people. Yes, Tanner?
Why don't we do the D?
Because the 4s gets filled energy-wise before the 3d. That's why I have this diagonal rule. So you would do 3p, 4s, then you'd fill 3d.
Oh.
So 3d would be next. How many can fill the d?
10.
10, right? Because it has 5 orbitals. The d does, right? 2 each. So you got 10. Where are we at? We're at like 30 something, aren't we?
Yeah, 30. Exactly.
10, 20, 30. Okay? We need 2 more electrons. What comes after 3d? 4p, and we would finish by putting how many in there?
2.
Let's check to see if this matches up. We go to the 4th, this is my last electrons, right? We go to the 4th energy level, find the what block? Find where? What do we finish in? Which orbital? P, right?
P.
Find the P. Here's where your P starts, and we put 2 in that 4, right? 4P. 1, 2 in would be what? Germanium.
It's like something.
Orbital notation. Guys, if you've done this, then really all you need to do is, there's your 1s, da-da-da-da. There's your 2s, da-da-da-da. Your 2p has how many orbitals? 2 each. This takes forever. I hate orbital notation.
Orbital notation is not the most convenient.
Okay, then comes 3s. That only has 1 orbital, correct? S only has 1 orbital, right?
Yep.
Does it matter if you put the up arrow or down arrow first?
No, doesn't. 3p we know gets completely filled based on what we just did with electron notation.
Might have.
Holy D! Okay, how many orbitals do I need to show for the D? How many orbitals for D? 5. 5, right? 1, 2, 3, 4, 5. Whew. Now I know I should be filling 1 before I fill the other, but if I know it's going to be completely filled, does that make sense? Finish with, I should, alright, 1, 2, 3, 4p, like this?
Nope.
Nope, what I do wrong?
You put them together, it's supposed to be separate so they can stay.
More
Wow,
energy efficient and more stable to do that.
1, 2.
Okay. There should be 32 arrows in there.
Why do we do this?
All right, let's do the noble gas one. Let's approximate quite a bit here. Wait a second. Did I miss 4S? I did. Ooh.
Oh, I got mine.
That's a
I got
crucial-
mine.
All right, guys. I forgot 4S in here. There's not.
We need to erase level 7 on the diagonal.
You guys see what I did wrong?
Yeah.
I just forgot to do the 4S. Okay? Noble gas. Again, let me review. Noble gas, how this works. Find germanium. This is more important that you pay attention on this one. Because I don't think orbital notation is annoying more than it is difficult. Noble gas can save you a whole bunch of time, but it is the hardest to understand right off the bat. So germanium, what did I say?
Up one.
Up one, find the noble gas, argon.
Your table already gives it.
Yes, it does. That's why I'm not letting you have that on the. Dang it.
Wait, what?
The table gives noble gas notation. It's right here. This is the noble gas notation for everything.
That's great.
That's why you may not have it.
Did I get that right?
Let me show you how to do this. Okay, argon, how many electrons does it have?
18.
18 electrons. So we are going to abbreviate 18 electrons. We're going to continue or start after argon. So let's figure out, where is argon's last electron located?
Is the
Well, look at the periodic table. What energy level is it in? What energy level? It's in the third energy level, right? And it's at the end of the what? P. So its last electron would be in 3p. Well, what then comes after 3p?
4S.
4s, and that is where we start. 4s, same thing. What's after 4s?
Wait, why'd you put 4S after
3D.
Ah! Darn it, that goes there.
Yeah.
I'm so
Jeez.
Okay.
3D.
Sorry,
That's
guys.
pretty easy.
What comes after 4s? We look up there, 3d.
We can just copy what we did for electron.
Kind of, yeah. And then 4s, 4p. I'm struggling, guys, here for a second.
That's dope.
Now let me show you what this did. What this did here was abbreviate 18 of the electrons up here.
Wow, that's great.
This got abbreviated by this. Notice how this is what's following.
So, could you kind of mix?
Everybody see that? This is abbreviated by the argon. 2, 4, 10, 18. Doesn't that the 18 electrons that argon would have?
Wait, so what would you do if, like, the argon didn't completely fill?
It always does.
Your noble gases will always fill a P sublevel because they're at the end of the P.
Question.
Yes, Tanner.
Why is argon 18, but that's only 14?
That's 18.
So 18 plus 14 is
Oh,
32.
okay. I thought we were.
This little brackets here abbreviates these 18 electrons.
All this stuff.
This is so fun.
It's the
Forget what day it is.
Honestly,
It's tomorrow.
It is tomorrow. You are right.
What's tomorrow?
I asked him yesterday if I could see stuff.
Like 12 times.
Why does this girl always get pushed back?
Mountain Lane.
Well, if I'm like,
Hey, guess what? Guess what? Oh, guess what can you know gas station?
So I could ask you to do the noble gas notation of Unum Noctium.
Guess
One year, students came in and did the electron configuration for Unum Noctium on my board.
Why did they do it?
They filled up the whole board.
Guess what has
They
that?
did 118 electrons up there.
That's a waste of time.
Guess what has that?
wait, what's the simple?
Why did they do noble
No
gas?
gas station.
I did. We can do that.
I mean, you can tell like some of them just like the last time.
I have a silver memory.
We're going to.
How about you calculate the schedule?